Hi everybody. So this is how I'm going to post some of my videos, especially these videos where I'm going to be covering a material that should have been covered before you started calculus. So this is a sort of series of pre-cal videos. Okay. So the first thing that is very important for calculus 1 is factoring polynomials. Okay. So first of all, what is a polynomial? Well, polynomial is just an expression consisting of variables, right? And their exponents, so x squared, x cubed, and so on, where the exponent is just it's an integer, right? And coefficients, which are constants multiplying these variables. Okay, so for example of polynomials would be 1 plus 3x plus 2x squared, or usually we write the highest exponent at the beginning, so x to the power of 10 minus 3x to the power of 9 plus 7 over 8 x to the power of 3 plus, let's say, the number pi x squared plus x plus 1. Okay, so this is another example of a polynomial. Okay, so as you can see, the exponents here have to be whole positive numbers and always this constant, which you can interpret it as x to the power of 0. So again, I'm reminding you that x to the power of 0 is equal to 1. Okay, so this video is about factoring polynomials, and we're going to start with the easiest type of factoring, and that's factoring out the greatest common factor. So video 1, part 1, factoring out the biggest common factor. And many of you have already done this. As I said, this is just a review. Okay, so what does it mean? First of all, to factor something, it means that to be able to express the polynomial, okay, as product of a one or more factors. Okay, so for example, okay, let's start with the easiest one, 3x minus 3. How am I going to factor this polynomial? Okay, so as you can see, this is written as a sum, or in this case difference, between these two terms, 3x and 3. Okay, but both of them are multiplied by what? By the common factor, in this particular case, 3. In that case, I factor 3 and I open parentheses. Please be very careful with these parentheses. Okay, they're essential in mathematics and especially Cal 1, so I encourage you to be extremely careful and always to use them. So with what do I have to multiply 3 as the first term that will appear here in order to get 3x? Well, of course, that's x. Okay, copy the sign, minus, with what do I have to multiply 3 in order to get 3? Well, 3 times 1 is 3. And that's how we have factored our first example. Okay, it was a very simple example. Let's do something slightly more, just a little bit more difficult. Okay, so we have 12x squared minus 18x. Okay, again, I'm looking for the biggest common factor. Okay, first let's see whether there are some common constants. Yes, that's 12 and 18. Both of these are divisible by 2, so 2 is a common factor. Also, both of them are divisible by 3, so 3 is also a common factor, but I'm looking for the biggest one. So if it's divisible by 2 and by 3, then it's definitely divisible by 6, right? So 12 divided by 6 is 2, and 18 divided by 6 is 3. So that means that the biggest common factor, 12 and 18, is 6. So I factor out 6. Now let's look at the variable. Here I have x squared, and here I have x. So the common factor is x. Okay, and it's the biggest one. Be careful, it's not x squared, because this term here doesn't have x squared. It has to be biggest common factor. So the common factor here is x, and now you proceed by the same idea. With what do I have to multiply 12x squared? With what do I have to multiply 6x to get 12x squared? That's 2x. 2 times 6 is 12. X times x is x squared. Minus, I have 6x, right? With what do I have to multiply 6x to get 18x? Well, that's simply 3. Let's do another example. Six a cubed b squared minus 3ab plus 30ab to the power of 4. Now I have to factor out this. I'm looking for the biggest common factor. Let's start with the constants first. So that's 6. Here I have 6. Here I have 3. Here I have 30. What is the common factor for all of this? Well, that's the number 3, because it has to be the common factor for all the elements, right? So that's the factor 3, and in that case it's the biggest one, because if I take any factor bigger than 3, this one is not going to be divisible by that, so I take out 3. Now let's see the factor of a. Here is a cubed, here is a, and here is a, so the biggest common factor would be just a, okay? And similarly with b, here is b squared, here is b to the power of 4, so the biggest common, it's very important here, common factor is b, right? The biggest factor of b is b to the power of 4, but b to the power of 4 is not common to these two, right? B squared is common to this one and this one, but not this one. So obviously the biggest common factor is just b. And then again, I open here, you can open parentheses or square brackets, that actually is not going to change anything. With what do I have to multiply 3ab to get 6a cubed b squared? Well, first, in order from 3 to get to 6, I need to multiply it by 2. Then with what do I need to multiply a to get a cubed? That's a squared. And with what do I need to multiply b to get b squared? Well, that's just b. Minus, with what do I need to multiply 3ab to get 3ab? Well, that's just the constant 1. And finally, in order to get from 3 to 30, I need to multiply 3 by 10. I have a factor of a here, and I have a factor of a here, so I multiply a by 1 to get a, so I don't have to write anything here, right? And then in order to get from b to the power of 4, I need to multiply that by b to the power of 3. There's always a question, can I factor any further? Well, 2 is a common factor for this one and this one, but not the one in the middle, so I cannot, that means it's not common for the whole expression. I have only a in this term, I don't have a and a here, so a is not a common factor, and I have b only here and not here, so that means that also b is not common factor to the whole expression. So our factoring is done. Okay, so let me just show you how we're going to solve equations by factoring. And now it is very important for you guys to solve quadratic or cubic and so on equations in the following way, by factoring. Okay, so the theorem is that if the product of two factors is 0, then one of the factors has to be 0. Okay, so for example, if I ask you to solve this equation, x squared is equal to x. Okay, how are you going to solve this equation? Okay, so I will show you how you should not solve this equation. Okay, if you have this equation and you say, okay, so now I can divide both sides by x, right? Divide both sides by x. You cancel x squared with x, you cancel x and x, and what do you get on this side? X squared divided by x is just x divided by x is 1. Is this a correct answer? No, because you just lost a solution. So never solve equations in this way, okay? Now I will show you the proper way how to solve it. So x squared is equal to x. First bring all the terms on one side of the equation. X squared minus x is equal to 0. Okay, can I use this theorem at this point? No, because it says if the product of two factors is 0, I don't have any factors here. Okay, what is the factor? So I need to factor an x, and then I get x minus 1 is equal. Okay, so now let us check whether or for what values these two factors can be 0. So either x is 0, right? Or x is equal to 1. And those are the two solutions of this quadratic equation. X is equal to 0 and x2 is equal to 1. What is the difference between this correct way of solving it and this way? Well, you lost a solution. If you do it this way, you lose an information about this equation. You lost a solution, x is equal to 0. So always try to solve polynomial equations by factoring.